In this tutorial, we'll be looking at the derivative tools, which are found in the Derive suite of icons. We'll be looking at the point cloud, Derive segment, Derive face, Derive a 2D wall, Derive a 3D extrusion, point extrusion, and Derive a 3D wall. These tools are used to derive new objects from existing objects that are already in your scene. We'll begin by creating a sample object. Select the 2D rectangle tool and we'll extrude a rectangle. To subtract some of the material from that, we'll select the circle tool, and in the tool options be sure to have the insert option on, and we'll draw a circle right on the top of the box, insert it, and subtract that part of the object. First, we'll look at the derivative point cloud tool. With that tool active, simply click on your object, and a point cloud is generated from the internal topological points that make up that object. Undo the operation, and now we'll look at the Derive segment tool. Simply click on the edge of an existing object, and a new segment is created from that edge. Undo that operation, click on the curved edge, and we get a segment from that portion. Undo the operation, because next I would like to show how you can derive from multiple edges of the object by holding down the Shift key. With the Shift key held down, select multiple edges, let go of the Shift key, click a blank area, and now we have one segment that's derived from the multiple edges that we selected. And that's because the default options for the tool is to join all the selected segments together as one continuous segment. If you'd like for those to be separate segments, then we can undo the operation and do it again with the each selected segment separately option turned on. Now if I hold down the Shift key, select my multiple edges, let go of the Shift key, click a blank area, and now we have three different segments that are derived from those pre-selected segments. Undo that operation. With the Derive Face tool, we can derive a brand new surface from existing faces on our objects in the scene. For example, with that tool active, I can select the side face of my object and it generates a new surface. If I undo and select the front face, then I get a new surface from that part of the object. Just like with the Derive segment, we can select multiple entities at the same time. For example, we can hold down the Shift key, select all three of the front faces, let go of the Shift key, click a blank area, and now I have one surface object that is generated from all three of the previously selected faces. And it is one object because we have the default setting of join selected faces. If we want those three to be separate, then we can do the operation again by choosing the each selected face separately option. And now if I hold down the Shift key, select my three faces, let go of the Shift key, click a blank area, now it generates three different surfaces from each of those faces. Next, we'll look at the Derivative 2D Wall tool. With that tool active, we can select any face of an existing object, and the 2D wall profile is generated from the boundary of that face. There's plenty of control parameters to modify the justification, such as left, right, or center from the original boundary of that face. We can also modify the wall width, either numerically in the tool options or dynamically here in the modeling window. Undo the operation, and we can also use the 2D wall tool on a single edge of an object. If I select just the curved portion of the object, then I get a 2D wall profile that's derived just off of that single edge. Undo, and I would like to show that you can also select through multiple edges. Just like in the previous tools, if I hold down the Shift key, I can select multiple edges of the object, let go of the Shift key, I click a blank area, and now the 2D wall profile is derived from all those edges. The Derivative Extrusion tool extrudes a new object off the face of an existing object. For example, I can take the 2D rectangle and extrude that into a solid object. I can take the circle and extrude that. I can take an open line profile and extrude that into a surface object. And I can take the 2D wall profile and extrude that into a solid wall. This tool also works on three-dimensional objects. For example, I can select the side face of this solid object and extrude a new object that's derived off the boundary of that existing face. It should be mentioned that the tool options contains two parameters. We can extrude either perpendicular to the existing surface or perpendicular to the reference plane. Let's look at an example of both. If I were to undo, I will temporarily move the bottom segment of the object by selecting the Move tool, holding down the Command key Mac or Control key Windows, and moving just the bottom segment of that object to create a sloped surface. Now when I use the Derivative Extrude tool, I will try the first option, which is the default, which is perpendicular to the surface. So when it generates the new object, you can see that that object is generated perpendicular to that existing surface. If I were to undo, I can select the perpendicular to reference plane option, and now you see our default reference plane is down here. And if I were to use the Derivative Extrusion tool and extrude a new object off that face, you can see it is extruded perpendicular to the current reference plane. The Derivative Point Extrusion tool behaves similar to the 3D Extrusion tool. However, the convergence is applied to a single point. For example, if I were to select my boundary and extrude that, you can see the extrusion goes to a single point location. If I were to select the top face of the object and extrude that, you can see you can also move the convergent point location. By default, it's in the center, but I can also move that point convergence, maybe snapping it to the front part of our object like that. And this tool also contains similar options to the 3D Extrude tool, which are the perpendicular to surface or perpendicular to the reference plane. And the last tool we'll look at is the Derivative 3D Wall tool. With that, we can select our entity and extrude that into a 3D solid wall. In the tool options, we have similar parameters to the 2D wall extrusion that we looked at earlier, such as the justification, which can be left, right, or center of the original selected profile, and also the wall width. We can also use this tool on closed profile shapes. For example, we can take this rectangular shape and using the Derivative 3D Wall tool, extrude that into a solid wall. With closed shapes, we have two additional parameters that we can select from, which is top and bottom closed. If the bottom closed is selected, then we get a floor slab of whatever thickness is defined in our thickness parameter. We can also close the top, which gives us a ceiling slab. And if we turn on a clipping plane, you can clearly see the results of using the top closed and bottom closed parameters in the Derivative 3D Wall tool. And similar to the other derivative tools, the 3D Wall tool can be used on 3D objects. For example, I can select the top face of our object, and a 3D wall is derived from that boundary. Once again, we do have our parameters to further modify any of the parameters associated with that three-dimensional wall. And this concludes the derivatives tutorial.